Alright, so today we're going to be doing day 19 in Advent of Code. And today's first part of the challenge is that we get a bunch of towels with different colors. W is white, blue is U because B was taken by black, R is red, and G is green. So with all of these different towels, we have different towel patterns. So we have a blue and then white and then, black, white, and then blue. And with all these different patterns, we want to see, is it possible to somehow combine these patterns to make these final patterns that they want us to make? And each line is a new different pattern that they want us to make. And there are a couple of rules. We cannot reverse them, so we can't make from BWU into UWB and then somehow put it somewhere. And also, we can use the same towel as many times as we want. So if there is a pattern that's 50 R's, then we can just use the R towel 50 different times, because they say that we have unlimited towels available of each different type. So if we look at our input, this is how it looks. So there's a bunch of different towel patterns that we have, and there's a bunch of wanted patterns that they want us to make. And what we have to return is, okay, how many designs is possible to make? So if there is, 1,000 designs here, we have to say, okay, how many of them are possible? And then just return a number of how many designs are possible. So to solve this, I've put the input into a file, and we can see that all of the towel designs and patterns are in one line, and then the rest of the wanted towels are in here. So they want about 400 towels. And the first thing that we can do is we can just put everything into lines, and then we can parse the data, and we can do that by finding the \n character, which we can see there's an empty line here where the data splits, so between the patterns that we have and the patterns that we want. And then what we do is we put in raw patterns the patterns that we have, and then we put it into total patterns once we've stripped it. And we do the same for the raw designs. We just take care of the formatting to put it into the designs. And then once we have all the designs, we iterate through all of them, and we made a function called can_construct_design, which returns true. And if it is true, then it means that we have one possible design, so we add 1 to this counter, which we will then print. And if we look at this function, it's recursive, so we start with the entire pattern. So if the entire pattern is ABC, then we start with the entire thing. And what we do is, if it's not in the design, meaning that if the design that we gave it is empty, then we return true. But since there is a design, so if this example is ABC, then the design will have ABC, so it will not return true right now. But the more it calls itself, you will see that it will eventually return true. So we go for each pattern in the towel patterns. So for each different pattern that we can see here, it iterates through them, and it sees, okay, is the design from the beginning until the length of the pattern equal to the pattern, meaning that, okay, the design from the beginning until the length of the pattern. So if we're looking at this one right now, so until this length, because it's only one long, then is this A equal to this A? If it is, then correct. So it goes forward, and then it does a if statement. If, and then it calls itself recursively, if the design from the beginning, not the beginning, but the beginning of the length of the design pattern. So from 1, so from here until the end, this means until some other index, but since we didn't put anything, it just means until the end of the pattern. So we give it B and C right now. Then it calls itself again, it sees that this design is not empty, and it checks for a new pattern that matches. Eventually it will find the B. It will go through A and B again, because we can use the same patterns again, which is great, because otherwise we would have to have a list of the ones that we've used, so we don't use them again, or pop them from the list that we're using. So it's just easier that since we can use the same towel as many times as we want. So then we use B, and then we check again if from the beginning to the length of the pattern, the beginning being here now until here, are they the same? They are. Great. So then we just send C. Then we send C, then we see that C is also a pattern that exists, so it's okay. And then what it will do is it will return from the length of the pattern, so from here until here, so it will send nothing. So now that it's empty, it will return true, meaning that we have found a pattern for every single letter or color, and we will return true, which will return true here. So this if statement will go in, and then we'll return true again, and so on until it goes all the way up from the recursive tree, and then we will add one to the possible designs. And we do this for every design, and then we print it. And if we run it, we can see that it's pretty fast. Takes maybe a second to run. And one thing that you may have noticed is that I've included cache. But if we take away cache, we can see that it runs pretty much at the same speed. It's not really too much faster. Okay, maybe a little bit slower. But basically what cache does, since we know that this function will return a bunch of times, so if we have the ABC and we know that this is true, if we then have, let's say, Z ABC, we already know that it is possible to do this ABC, so we just return true. So then we only have to check if it's possible to also add Z somehow to it. So the cache function just caches the result of this function with a specific design. So if we give it ABC, and it will do its thing, and then it will return true. Next time, if we use ZABC, it will see that, okay, it will take away the Z first, and then it will have the ABC again, which it knows that it is true, so it does not have to recursively go all the way down to make sure that it's true. So cache does make it faster, it's just that it's not complicated enough right now for us to see a difference. But in part 2, we will see a difference. So let's go to part 2. What they want us to do now is, instead of seeing how many of them it's possible for us to make, we want to see how many different ways we can even make a pattern, because apparently there's several ways to make a specific pattern. And then once we get all the different patterns for all of them that are possible, we add it together and we return a number. So if we look at the code, we import cache, we read it again, we parse the information, and we can see if I look at it side by side, they're basically the same. It's just this function that we've changed, and a little bit in the for loop here, because now what we do in this function instead is we return a total ways, which we can just add to total ways for all of the designs. So it goes through all the designs, it gets a total, and then we print it, of course. But instead of returning true or false, we return how many ways it's possible to do this. So we do the exact same thing, where we check if the design is the same as the pattern from the beginning until the length of the pattern, and we recursively give it again the same exact story. But when it reaches the base case, so in this case in part 1, the base case was if not design. So it's the same thing here, if not design, then it means that it is possible to do it with that specific pattern. So we return 1 with that specific pattern, which will be added to the total ways. And then we keep checking with different patterns. Is it possible? And if it is, then it will check and tell us that it is possible with a different way as well. So it will check all the different combinations of patterns that it is possible with and add it to the total ways. Then we will add it to the total ways for all designs. And if we run this, we can see that we have cache enabled. So all you have to do to enable cache is import cache from functools and then say add cache right before a function that you would like to cache. Then we can see it took maybe 2 seconds, 3 seconds, 4, 5, 6, took a little while. But now if we remove cache altogether, then you will see that this will basically take forever. So I will leave this in the background as I talk about the time complexities. So just know that it's a lot slower without caching, since now we have to iterate through a lot more things. So to talk about the time complexity of part 1, we have T, D, and N, which is T, the total number of design of patterns that we have. D is the average length of a design. So if the design is really long and then the pattern is just half a design here and half a design there, then it wouldn't be that difficult to find. But the smaller the designs and the longer the wanted design, the longer it would take. And then N is the total number of designs. So the time complexity in this case would be N times T to the power of D. So we have how many towel patterns we have to the power of the average length of a design, because that is how many times we will have to fit these into this. And we have to iterate through all of these to be able to find the necessary amount. And for the space complexity, it's N times D. So the total number of designs times the average length of a design, which is not too bad. And then if we look at part 2, actually it's the same, but the reason that it's the same is because we have the same recursive function. It's just that now it also returns a number, so it takes a bit longer if we don't do it with caching. But if we use caching, then we saw that it takes basically the same amount of time. So if I put caching again and then I run it, we see that it takes just a couple seconds. And I also opened this code because in day 11 we've also used caching, so we can see that it can be really useful to use caching in Python to make the code a lot faster. So this was the answer, 642 something something, and if we look at the answer here, that is the correct answer. So that was the challenge for today. If you guys want to join the leaderboard, I will leave the code in the description. And thank you for watching, happy holidays, and see you tomorrow.